Okay. Now, what is in the agenda for today? Well, in the agenda for today, let us say last time we did started with loops, right? Let me just confirm. I didn't start with loops as far as I remember. We started with if else, but we didn't start with loops. This was the file. Yes, and the last was if else. Today we are going to start with the loops as well. Okay, we'll create a new book for you. Loops. Now, as far as loops is concerned, let us initially, as usual, focus on C programming. In C programming, there are two types of loops. Oh, yes, I think we did one program on loops. Did we? Yes, I'm pretty sure we did one program on loops, right? Last time, while this, I can just open my drive so that it is available in Python as well for the file which we usually do. So yes, take this out. Yes, this was the collab file. No, we were only in the if else part. Okay, in C programming also, this was the last program that we did. Okay, no problem. So I think we should get started with this now without wasting a single minute. A lot of things to be covered. So to start with, let me just try to figure out which is the program that we can go ahead right now. First, what am I going to do is aim over here is to cover this program. But before I go ahead with this, we should at least understand the basics of loops. So I will start with this program, and consecutively we are going to move to this program to display the prime numbers between 75 to 150. And after this, today, sorry, after this today, we are also going to start with the functions topic. Okay, so here, as I told you, we are going to start with this particular thing, and I'll clear this off. Let's say initially I'm planning to write a program to display the first 20 natural numbers. Okay, let's take this pretty simple stuff purposely. Good evening all, good evening all. So let's say so we have to write a program to display the first 20 natural numbers. Now, before I go ahead with this, it's very important for us to get acclimatized with the syntax. How do you have loops? When in C, you have three types of loops. One is called as a for loop, one is called as a while loop, and one is called as a do while loop. Not everything is important at the moment. Let us go across and come across the loops as and when we have a need. Initially, let us talk of a for loop. And what is the syntax for a for loop? For followed by initialization, then a semicolon, then we have condition, then a semicolon, then we can have either an increment or an decrement. And inside this, I can say, do this, so on and so forth. Again, over here, if there is only one do this, then we don't require brace brackets. Point number one. So let's say if I have a variable I which is declared, and if I say for I is equal to 0, I is less than is equal to 5, I plus plus, I say printf hello and printf on a new line Shikuya. Okay, that is the end. If you do this, let me tell you what is the going to be the flow of the things. Well, the output of this, first and foremost thing, variable I is going to be initialized to 0. So variable I will be created that would be initialized. I'll just say variable I would be created and that would be initialized to the number 0. This is done. Then it will check. Okay, after this control goes to here. It will check is 0 less than is equal to 5. Yes. If it is the allowed, if this condition is satisfied, I go inside and I print this. So what is the message? Hello. And on the next line, Shikuya. Thereafter, from here, there is nothing to execute. Now the control goes up to I plus plus. So I will become 1. Then you come over here and check is 1 less than is equal to 5. Yes. Come down and again print the same set of statements. I'll not write it again. Same thing would be printed. After this, control goes back and I plus plus. So I becomes 2. It will check now after this is 2 less than is equal to 5. Yes. Come down and get the same 2 lines as the output. Then control goes back. I plus plus I becomes 3. Is 3 less than is equal to 5? Yes. Come down, execute the same set of lines. Again, come back, I plus plus, that becomes 4. Now, once this is 4, it will check is 4 less than is equal to 5? Yes. It will print the same lines. Then it will go back I plus plus. Once again, it will say 5. Now it will check is 5 less than is equal to 5? Yes. So it will once again print the same set of lines below this. Now it will go back and it will say I plus plus where I's value will become 6. And once this becomes 6, it will check now. Is 6 less than is equal to 5? No. If this condition is not satisfied, I don't execute this. And therefore the output is printing hello Shikuya. How many times? Total 6 times. And you know what is the best part of it? If I have to convert in Python, okay, this is syntax for C now. If I have to convert in Python, well, in Python, the things are very simple. You need not do anything. Okay. I'll come to Python later. Okay. Let's not talk of this right now. Initially, let's talk of C only. So let us say, this is how I do my things. Okay, yesterday's session is already there on YouTube. If you still have any questions regarding that, please visit their website or contact the right person from Shikuya, because I don't exercise any control over it. Okay, so please contact the right person from the academy. He or she will definitely help you on that Saptarshi. Okay, and it is there on the YouTube only. You just search for their channel and you'll be getting it in the yesterday's uploaded video only. Okay. Now, I was like, now we have to display the first 20 natural numbers. So as usual, first thing, hash include stdio.h. Then we write void main. Inside this, I'm going to declare a variable I, and then I say for I is equal to first 20 natural numbers. So obviously we know the expected output is what? The expected output is 1, 2, 3, 4, 5 up to 20. Okay. So I say my I over here will be starting from 1. I will be going up to 20. I plus plus. And I say, what do I have to do over here? I just need to print the value of I. So I don't require a brace bracket. Printf %d, comma I. And every I has to be printed with few spaces. So I just leave three spaces over here, and that's it. Now I say, let me run this, choosing a language, C, and yes, you can see the numbers. You can see the output 1, 2, 3, 4 up to 20. That is too simple. Okay. This is not what is asked, but this is just to make you familiarized with the structure of the program. Okay. Now, after this, let's say, next I say I want to display the sum of the first 20 natural numbers. Okay, I have to display the sum of first 20 natural numbers. So to get the sum of first 20 natural numbers, what will I do over here is, first of all, how do I get the natural numbers? I know first 20 natural numbers. So my for loop I is going to go from 1. I is less than equal to 20, I plus plus. But this time I don't want to print the value of I. I want to calculate the sum. So I'm going to declare a variable sum, and initially we are going to set it to 0. So let's have a variable sum which is set to 0. Then coming inside this, I say sum is equal to older value of sum but plus the value of I. Let us check it out. What is the value of I? Value of I is 1. Is 1 less than 20? Yes. Come down and say sum is equal to sum plus I. That is 0 plus 1. What is the answer? 1. Store it inside sum. That's what I did. Once I did that, I go up, I say I plus plus. So this will become 2. Once this has become 2, I come over here, check is 2 less than equal to 20. Yes. Sum is equal to sum plus I. So now it will be 1 plus 2. That will become 3. It goes up, I becomes 3. Okay. After that, it will check is 3 less than is equal to 20. Yes. Sum is equal to sum plus I. 3 plus 3, 9. And in this way, it goes on till the time it reaches 20. So if I just code this logic, so I say I'll be requiring another variable called as sum, which I set to 0. And I say sum is equal to sum plus I. If you don't initialize it to 0, by default value in C will always be garbage value. So it must be compulsorily initialized by 0, as default value is a garbage value in C. So now I have done that, and next I say printf, I want you to print the value of sum. And I run this, and you can see the sum of the numbers came out to be 210. That's correct as well. If I say here I want the sum of first 100 numbers, I just need to change the code over here to 100 and run. And you can see the sum of first 100 number is 5050. So basic thing. Okay. Then it is visible. Vidyashri, screen is visible, else most of you, I mean, everyone might have said that. Please check at your end. I think you might be having a weaker connection. That could be the reason for it. However, I'm using a very high quality connection. So from my side, if there is any issue, I mean, the chances are rare of the rarest. Okay. Saptarshi, I don't exercise any control over it. I think a better person to contact is going to be from the Shikuya team regarding all these videos and all. So, yes, of course, Ujjwal, you can do it, but that doesn't mean, okay, as you said, Ujjwal, you can definitely do it by saying n is equal to n plus 1 divided by 2, but Why to do it? In this case, it's fine. But do you mean to say by that, Ujjwal, that you never ever will be requiring loops? Obviously not. Maybe this program can be done, but what about others? So loops are certainly required. No doubt about it. They are certainly required. Okay. No, there should be no reason for blurring. Ajay, do you see any blur effect on YouTube? Because I can see it very clearly on YouTube. If you observe, see, this is the YouTube live stream.
No, all is okay. All right.
Perfect, now.
Yes, yes.
Okay. If I just confirm the quality is 720. It's correct. It's perfect. Okay. No. Okay. So now this is fine. After this, as I told you, this is not the main aim. The main aim is this: program to display prime numbers between 75 to 150. You know why am I taking this question? Because if you observe this, these all are the set of the questions which come from the TCS NQT part. And one of this is this question: write a program to find how many prime numbers are there between 25 to 125. So rather than discussing this code directly, I think we should first understand how to define a code to determine whether a number is a prime number or not. Okay. Now, okay. To start with it, what is the question? Well, we need to find out, or let's say we need to check whether a number is prime or not. Point number one, let's try to figure out what is a prime number. A prime number is a number which, when, what is a prime number? Prime number is a number which cannot be divided by any other number other than itself and 1. So I say 7 is a prime number because 7 can't be divided by any other number other than 1 or 7. So if you take 2, 3, 4, 5, 6, 7 is not divisible. Even if I take 13, 1 or 13 is an exception. Other than that, 2, 3, right up to 12, none of these numbers can be divided by this. That's very much obvious. So now, if we use this particular logic for identifying whether a prime number is prime or not, well, then I can say that let me take a number as input from the user. So I say write a program to identify whether a number is prime or not. Okay, proper TCS question. Let's go ahead. First, hash include stdio.h. Then we write void main. Next thing is we are going to take a number as input from the user. Let's call it as n. Okay, that is the number which user is going to give. And I'm going to require a for loop. So I started over here. Then I say printf, enter a number to be checked for prime. Then we say scanf %d ampersand number. Okay. Now how to check whether a number is prime or not? Let's say I start a for loop. My for loop is going to go from I is equal to 2 to I less than number I plus plus. And here what I need to check over here, if Right from 2 to a number less than n, if that particular number modulo 2 becomes equal to 0. Well, we have to understand over here that modulo gives remainder. Modulo is going to give me remainder. So it is like if I have a number maybe like 13, then it is going to check, is 2 modulo 13 equal to 0? Is 3 modulo 13 equal to 0? 4 modulo 13, 5 modulo 13, so on and so forth till it reaches 12. And if that is a condition, then we say printf number is prime, or we can say %d number is prime. And what is the %d value? N, not number, sorry, n. Else we say % number is not prime. Now look at this, why this program fails. First, let's try to understand what is it going to do. Well, things are going to be very simple over here. It is going to take the numbers. When I say number is equal to 13, so is equal to 13 and I is equal to 2 to less than n. That is, I is going to take the number 2, 3, 4, 5, right up to 12. And every time it is going to check, is 13 modulo 2 is equal to 0? Yes or no? Then it will check, is 13 modulo 3, is it equal to 0? Yes or no? So on and so forth. It will check till 13 modulo 12 is equal to 0 or not. Yes or no? And every time, depending on the condition, if it is yes, it will print this message. If the output is no, it is going to print this message. Let us figure out. So I say executing this, it will ask me for a number. Let's say I give the number as 7. So you can see over here, let us include a \n for better clarity. Run 7. Is he gone insane? Why is it printing so many number of times? 7 is not prime, 7 is not prime, 7 is not prime. And if I do the same thing with 13, 1, 3, it is printing it more number of times now. 13 is not prime. How many times it printed? My God, which is not correct. So how to tackle this problem? Well, let us first try to figure out why did it do it. Then we'll see how to tackle this problem. So over here, let us say, now for convenience, I'm going to take a smaller number, let's say 7. So if I think of this, if my number is equal to 7, here it is initializing I to 2, is 2 less than 7? Yes, condition satisfied. If condition is satisfied, it is going to check, is 7 modulo 2 equal to 0? No, this is no. So obviously it is going to print that 2 is not prime. Yes, it is going to print 2 number is not prime. So it is going to print 2 is not prime. After this, it's a for loop now. So from here it will go up, because this entire thing is going to be a part of the for loop, single line. Now here, after this I plus plus, so I is going to become 3. Then it will check, is 3 less than 7? Yes. Then it will check, is 7 modulo 3 equal to 0? No. Come down and once again print over here. And what will it print? Number, not 2, sorry, number. 7 is not prime. Again it will go up. I plus plus, I will become 4. Then it will check, is 7 modulo 4? Okay, is, it is going to be number modulo I. What am I saying? By mistake I did that. Number modulo I. So it is going to check over here, is my 7 modulo I is equal to 0? That is 7 modulo 4. No, it is not equal to 0. So again it will come to the else part and it will say 7 is not prime. So every time it is printing that, and therefore This is not the right way. I want to know whether a number is prime or not, and that too just one time, just one time. Okay. So you check for all the numbers and then immediately come and tell me whether the number is prime or not. Okay, fine. Now please understand. Here, what am I going to do? This time I'm going to use a variable which is called as flag. So I say over here, instead of doing this, let us use uh, a flag variable. Let's say not prime. So I say, or let's call it as flag only. Just a temporary variable. Okay? Flag is just a temporary variable where I'm assuming over here. Okay, let me write the logic over here. So I say, as per logic, I am assuming that if flag is equal to 0, it means it is not prime. And flag is equal to 1 means it is prime. Okay. So now I come over here, and after coming over here, by default, I'm saying that the number is not prime. Flag equal to 0 means not prime. Now I check for it. What do I say? I is equal to 2 to I is equal to n. If number modulo I is equal to 0, then I say I have found that the number is equal to prime. So flag is equal to 1. Flag equal to 1 means number is prime, and then straight away break the loop. Okay, sorted. Straight away break the loop, and I am done. Then I say, let's go down. Now I check if my number is equal to, or let's say flag. If my flag is equal to 0, we are going to print. I'll copy this from here now. Print that the number is not required. Flag is equal to 0, number is prime. Okay. Else we print number is not prime. And thereafter we are done. Let me first execute and check it. Let's say if I give a number like 7, only one time it is going to give the answer. Let me give a number which is like 100, which is not a prime number. 100 is not prime. So now what exactly happened? Let me very quickly explain you the logic, and then I can take up your questions if any. So I say, if I give the number as equal to 7, it is going to go from I is equal to 2. It will check is 2 less than 7. Yes. Come down and check, is 7 modulo 2 equal to 0? No. So after that, if that is not the case, I'll go back and I say I plus plus, so I becomes 3. Then 3 less than 7? Yes. Is 7 modulo 3 equal to 0? No. Again go back, I plus plus, so I becomes 4. 4 less than 7? Yes. Is 7 modulo 4 equal to 0? No. Again go back, I plus plus. 5. 5 modulo 7 modulo 5 equal to 0? No. Again go back, this becomes 6. It is going to come over here. Is 6 modulo n modulo this, that is 7 modulo 6 equal to 0? No. Again go back, I plus plus, this becomes 7. Is 7 less than 7? No. That means loop is over. That means it never entered this particular bracket. After this loop is done. It comes to the next line and checks, is my flag 0? We initialize it at 0. if it didn't enter this particular block, there is no chance of it becoming 1. So flag is 0, so it printed it as prime. But just imagine that if it happened to enter inside this, then it will make the value of flag as 1 and it will immediately break. What is break going to do? Break is going to break the loop. So we straight away break the loop and come to this line. So the moment we initialize it to 1, we are breaking, and breaking will straight away take us right to this line. And therefore, we are going to get the answer only once. Only once. So just save this. And now I'll just see if I can take your questions, if any. Okay. Okay. What X? I'll do that. Please make correction in the if else statement. Flag equal to 0 means not prime. It is correct, Ujjwal. 100% correct. You can see when we execute it, if I give a number like 73, which we know is a prime number, it checks it correctly. And Ujjwal, please correct your understanding. Small mistake. If I give a number like 120, 120 is not prime. It's correct, Ujjwal. Clear to you, Ujjwal? Then yes, modulo operator, I'll tell you. Just a second, Vortex, please observe. What is exactly modulo operator? Well, let's say if I have a number like 13, if I'm dividing it by 2, what is 13 modulo 2? Well, 2 6 are 12. Remainder is 1. This is what we know. Our teacher has already taught us in school. This is quotient and this is remainder. So if you do 13 modulo 2, what you get will be remainder. This is exactly what I'm talking of. Okay. Modulo operation is going to give remainder. Simple. Okay. Now, Sushant, there is absolutely no need to be over smart. I think we can understand the things step by step rather than showing unnecessary intelligence over here. This was not the end of the program. It is good that you know, but I think you know what happens over here. The other learners get intimidated. Okay, good, you know it. In fact, what you have said is 100% correct as well. I don't deny to the fact. But anyways, I was coming to this in the next point. Okay, fine. Now, so this is, Sushant, basically for no, so that other learners are also with me. My aim is not only to teach to Sushant, my aim is to teach to all the 100 people who are listening to me. Okay, so please let's respect each and everyone in this session. Okay, now friends, understand, if I have to conclude whether number 13 is a prime number or not, what did I say? You start dividing by 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? That is everything between 1 to 13, you divide by that. But if you logically see, okay, how to check it? Well, if you say 13 divided by 2, if I am looking at the quotient, okay, quotient, we know that 2 6 are 12. Then if I say 13 divided by 3, 3 4s are 12. If I say 13 divided by 4, 4 3s are 12. Then if I say 13 divided by next number 5, 5 2s are 10. I'm just looking at the quotients. 13 divided by 6, 6 2s are 12. Then 7. 13 divided by 7. Well, it is 1. 7 1s are 7. I can go to the number 2. Then if I take 13 divided by 8, I can go above 1, right? 8 ones are 8, remaining is 5. So the moral of the story is it doesn't make sense in going ahead. What they logically say is, obviously 7 twos are is straight away going to be 14, so it doesn't make sense in going ahead in unnecessary checking the thing. So the moral of the story is, rather than searching this entire space, better search, if the number is 13, better search only up to n by 2. So what is 13 by 2? 6. There is no need to search from this particular place. What will this do? It is going to straight away reduce our search space by half. Earlier, we used to divide it from 2 to 12. Now we are only dividing it till this particular part, and this part can be ignored. So what am I doing over here? I am making my program computationally faster by simply saying, instead of writing over here n, you just need to write n divided by 2. That's it. Okay, so this is something very important. Okay, now having understood this, having understood how to understand whether a program is prime or not, I think the next one which immediately comes into our understanding is, yes, our question. This is the most important part. Program to display the numbers between 75 to 150. Display all the numbers between 75 to 150. Let us do this. So I say, let's create a new project and save it by the name this, save, and get this. Okay, now what is the question? The question is this. Yes. Write a program to display the prime numbers between 75 to 150. We are not interested in understanding whether a number is prime or not. I want to display the prime number. So I need to identify if it is a prime number, display it. If it is not a prime number, don't display it. Simple. That is the main logic behind this. If it is a prime number, we are going to display it. If it is not a prime number, we are going to ignore it. And the logic for this is already clear to us. Okay. So how to figure out this particular thing for our better understanding? So if a number is between 75 to 150. Okay. So if first of all, I don't know whether I'll be requiring a flag or not. This time the things are slightly different. I require I. Then I say for I is equal to 75, I less than equal to 150, I plus plus. Yes. So I want to search in this particular space. Okay. In this particular space, what do I want to search? I want to search whether the number 75 is a prime number or not. Okay. How do I check whether number 75 is a prime number or not? Well, using the same logic. So I say, I'm using my for loop over here, which is going to go from another for loop. So I think we require one more variable this time. Let's say J. So I say, I want to check from J is equal to 2 to J less than, or to preserve the heritage, what I will do is, let us label this as J so that you will not be confused. So we need to check or find the prime numbers between 75 to 150. I say for. Now I use the same logic. My I is going to go from 2 to what? I less than n tha na pehle, n by 2. So I less than n by 2. What is n? Well, right now the first number which I'm checking over here, as you all know, is 75. I have to check from 75, then 76, right up to 150. So I need to check whether 75 is a prime number or not, whether this is a prime number or not, so on and so forth up to here, whether it is a prime number or not. So initially when I say j is equal to 75 and I am inside this loop, I am having the value of j as 75, and now I need to check whether 75 is a prime number or not. So I say over here, I is equal to 2, I is less than n by 2. What is the value of n over here? The number 75. So I can go by 75 by 2. I will be saying j by 2 because that 75 is stored inside j. And I say I plus plus. And I simply say over here, see now the things are pretty simple. I say if, okay, what am I going to write? If. So once again, I will have to use a flag variable. I'll do the same thing. I say flag equal to 0. Flag equal to 0 means not a prime. So I say if my number modulo I is equal to 0, coming inside this, I say flag is equal to 1, break. And here I say, after this for loop ends, if I can copy the same thing, if my flag is equal to 0, printf %d is not prime. And but let's say I am only interested in flag equal to 1. So if flag is equal to 1, I'll say % prime. Else I don't want to do anything. So I say over here that is going to be the variable I. Okay. If flag is equal to 1, I say number is prime. Now there is one catch over here. Flag equal to 0. Okay, this flag variable, this flag equal to 0 has to be initialized inside this. I'll tell you why. Okay, first let us check the output first, whether it is working as expected, and then I'll explain you the overall workflow of this. So no, number modulo I is equal to undeclared I. Okay, my if number modulo, oh, there is no number, there is j. Yes, I just need to decorate it properly. So I say \n. And yes, I can get all the numbers which are prime. No, I cannot print I have to print j, my mistake. And in fact, this is also not required. I can say this %d space. First, let it come and then I'll explain you once again. Run. Yes, as you can see, all of these are the prime numbers, right from 75 going up to 150. If flag is equal to 1, then only it has to display. So how can it take 150 as a prime number? Definitely there is some mistake in the logic over here that we understand. No problem. Let us try to figure it out. If flag is equal to 1, we are going to print it. And after that, this flag equal to 0. Okay. 75, 76. Flag equal to 0 means not prime. Okay, and if flag is equal to 1, you set it and break it. Once you break it, it will come over here. It will check, is flag equal to 1? Yes, then it has to print it. After that, it will go over here, j plus plus, j will become 76, flag equal to 0, I is equal to 2, I less than j divide by 2. No, not j divided by 2. I will go from 2 and j is going to be j divided by 2. That is fine. I plus plus if number modulo I is equal to 0, flag equal to 1 and break. And that number is stored inside j. Seems to be correct. Let me check it out. How the flag value will be equal to what? Just a second. Let me just check what is the small mistake. This is a very silly mistake. Just let me figure out. J75, it will go up to 150, J plus plus. That is fine. Coming inside, I set flag equal to 0. Yes, flag equal to 0 is not prime. Oh, flag equal to 0 is prime. Flag equal to 0 means number is prime. Then it is not prime. This now it's correct. Yes, it's working fine. Small mistake, as I told you. Let me explain this to you now. Everyone, please observe. Those who have questions, it is going to become crystal clear now, and then I'll ask you, did you get it or not? So, yes, let's start with it. First of all, understand, we are just taking flag. Okay, flag is not any other deadly variable. It is just like a temporary variable. You can give any name to this. So I have decided that flag is equal to 0 means not prime and 1 means prime. You can decide it the other way around also. Absolutely no problem. So I say j is equal to 75. So I have a variable j which is equal to 75. Now I need to check whether 75 is a prime number or not. So I come inside this and I say, is 75 less than or equal to 150? Yes, because we have to search in this space. Then once I say, okay, this is agreed, now this entire thing has to be executed. Now, if you closely observe over here, the first thing what I do inside this is I set my flag to 0. That means I'm saying that 75 is not a prime number. I don't know whether it is there or not, but I'm saying it's not a prime number. Then I say I is equal to 2 to I less than j divided by 2. So I am initializing a variable I to 2 and j is going to, or I is going to go from 2 to j divided by 2. So it is going to go from 2, 3, 4, 5, 6, 7 till 75 divided by 2. What is 75 divided by 2? 2 3s are 6, 2 7s are 14. So it is going to go from 2 to 37. And every time it is going to check whether 75 modulo this value of I, is it equal to 0 or not. If this becomes equal to 0 even at any particular point, then we set the flag equal to 1, indicating that the number is divisible in between. So over here, we clearly understand that yes, flag equal to 1 means it is certainly not a prime number. So here I check, is flag equal to 0? Yes, then print it as a prime number. So once it is done, again it will go back. Once it goes back, this time j value become j plus plus. So j will become 76. And then it repeats the same procedure for 76. It will check, is 76 a prime number or not. After this is done, again it will go back. J plus plus will make it 77. Again, it will check the logic whether it is prime or not. And this is the way it is going to go on, again and again. Yes. So now let me ask you, screen is clear, guys. I mean, screen is 100% clear. Spandana, the screen is clear. Please check your internet connectivity. Okay. Now let me ask you, is the logic clear? Prasan, that's what I said. Flag is just a temporary variable. Mahi, break statement was done covered yesterday. Please refer the yesterday session. Break statement is used to break the loop, Mahi. So whichever current loop I am in, that loop will be broken. Okay, so I guess you have joined today only, right, Mahi? Today is your first day, Mahi. Am I correct? Please answer, Mahi. Also, till then, uh, let me tell you, as a protocol, if you are from the coding background and if you have understood, we are writing yes. If you are from a non-coding background, you'll just write Y star. If you don't understand it, type no. And if you are from a non-coding background and if you don't understand, type N star. Okay. So Mahi, here, Mahi, what did we do over here is, if the number at any time, see what are we saying? Let's say the number is 7. We want to check whether a number is prime number or not. So every time we are going to say 7 modulo 2, is it equal to 0 or not? 7 modulo 3, is it equal to 0 or not? 4, 5, 6. We are going to check whether every time you check it, whether it is equal to 0 or not. And if it is equal to 0, we come inside it, set the flag. And what is break going to do? Break statement, as we all know, break statement is, it will break or terminate the current loop. So Mahi, if you observe over here carefully, break is used to terminate the current loop. And how many loops are running at the moment? This is the first loop. Oh, sorry, this is the first loop. And this is the second loop. Which is the current loop which is running? This is the current loop now, because break statement is inside this loop. So break will terminate this loop. It will not terminate the outer loop. So when I say terminate this loop, that means it will go on to the next line. So break is used to terminate the current loop. Get it now? Mahi? Yes, Aniket, please tell me your question. Aniket and Praveen, please tell me what question you have. Monica, we explained everything. Please, guys, listen to me. You have to focus 100%. Okay, we have already explained why it is j divided by 2. I'll explain this once again, but from now onwards, repeating again will be difficult. Huh? If you don't understand it, that's fine. But now, if you say repeat again, I explain almost this thing for 5 minutes. So, Monica, if I have to conclude, let's say if you want to conclude whether 7 is a prime number or not. So you will say, okay, let me check whether 7 is divisible by 2. Is 7 modulo 2 equal to 0? No. Is 7 modulo 3 equal to 0? No. Is 7 modulo 4, 5, 6 equal to 0? No. If every time it is no, we say that, okay, the number is prime. But honestly speaking, dividing by 2, 3, 4, 5, and 6, it's not required. If the number is equal to 7, it is okay if we divide up to number divided by 2, that is 7 divided by 2, that is 3. That is, we know 7 divided by 2, 2 threes are 6, remainder is 1. 7 divided by 3, 3 twos are 6, remainder is 1. After that, if I say 7 divided by 4, 4 doesn't even go in the power of 2. 4 twos are becomes a number which is greater than 7. Therefore, it doesn't make sense in dividing it further. Why will you unnecessarily keep time in, why will you unnecessarily waste your time in checking it? Simply by doing a small check over here, up to n by 2 is more than sufficient. We need not check for the other numbers because it is but obvious that they will not be prime. But for them to be prime, it has to be in multiples of more than 1. And here 4 twos are straight away becomes a number which is greater than 7. So it doesn't make sense to go ahead. So better stop over here. So only go up to n divided by 2 if the number is n. Hey, which live are you talking to me to press? Which live? Where is the live? I can't see. Which live? What is the need of plus plus? Plus plus is for increment. If you want to increment anything by 1, you write plus plus. So here, if I write I plus plus, then what does that mean? If the value of I is 3, I plus plus mean increment the value of I by 1. Okay. And if the value of I is 4, I minus minus means decrement the value of this by 1. Okay. This I plus plus can also be written as I is equal to I plus 1. And I minus minus can also be written as I is equal to I minus 1. Both are valid. Okay.
It's 6 o'clock.
Go ahead with beside the mute option. But what is the use of this? Unnecessary causing double screen. Okay, so let's go ahead. Now, after understanding this, the next question which we have is, okay, let us say factorial of a number and sum of the digits. Let's cover this factorial, then we'll cover factorial using recursion and sum of the digits. These all are very simple programs, but you have to go, yes. On the 4th day, we'll be starting with this advanced programs as well. Okay, you just need to hold on till this particular point. We'll be starting with that, but initially, simple one. So now that this is clear, I can save this, share this with you at the moment. Okay. Now after this, The next question, let's say factorial of a number. Okay, let's try to find the factorial of a number. We'll do that very quickly. So the question is, factorial of a number. Now, what is exactly factorial of a number? We understand that if I say, what is 5 factorial? That is 5 into 4 into 3 into 1. Okay, that is exactly 5 factorial. Or I can also say it is equal to 1 into 2 into 3 into 4 into 5. That is, now I can say that n factorial is n into n minus 1 into n minus 2 into dot 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 till 1. Or it is 1 into 2 into 3 into 4 into n minus 1 till n. Yes. So the moral of the story is this. This is how you calculate factorial of a number. Okay. Also, one thing that we need to note, that factorial exists only for positive numbers. It doesn't exist for negative numbers. Okay. So what will be the logic for calculating factorial? If someone says that, okay, you need to calculate the factorial of 5. So what will I say? Well, I will have to go from I is equal to 1 till I less than equal to 5, I plus plus. And every time, what will I have to do? I will have to say that my factorial is going to be factorial into I. Okay. What is this going to happen? First of all, understand I have to set this value as 1. And let me explain you what happens over here. When I say, this is the most important logic, factorial is equal to 1, I am setting a variable I which is equal to 1. Then I check, is 1 less than is equal to 5? Yes. Then I say factorial into I. What is factorial into I? 1 into 1. 1 into 1 is 1. Where to store it? Inside the fact variable. Let's store 1. Control goes up. I plus plus, this becomes 2. Is 2 less than 5? Yes. Calculate factorial into I, which is 2 into 1. 2 into 1 is 2. Where to store it? In fact. So this gets stored inside this. It goes up. I plus plus. 3. 3 less than equal to 5? Yes. Factorial into I. 2 into 3, 6. To be stored inside fact. 6. Go up. I plus plus I becomes 4. 4 less than equal to 5? Yes. Fact into I, 6 fours are 24. Stored inside fact. That stores 24. Now, upper I plus plus. Then is 5 less than equal to 5? Yes. Factorial into I, that is 5 into 4, 20. Where to store it? Well, oh, 24. 24 into 5, that is 120. Where to store it? In the fact. So this is going to store 120. Then after this, I go up and say I plus plus. I becomes 6. Is 6 less than equal to 5? No, that means stop. And now it is just about printing the value inside the fact, and it's done. Yes, that is the simplest way for calculating the factorial of a number. Yes, thank you very much, Monica. Yes. Yes. That's a very good question. That's correct. This will not work for big numbers. That's correct. So first, let us execute this and see. Now, what is the question? Factorial of a number. Let's create. And I say hash include, let it be there. We don't want this decoration stuff. I'll just remove that. And we say factorial of a number. Instead of this, I'll replace it by void only. We'll see what to do with these all things in some time. Then I say, let us first take a number. Int n, whichever number the user wants, he can take a factorial of. So I take the number as n. Then I say, I'm also going to take a variable called as fact and initialize it to 1. Don't initialize it by 0. Else, every time when you say fact is equal to fact into I, if the initial value is 0, then it will push everything into 0. It will be 0 multiplied by fact, 0 multiplied by this, 0 multiplied by this. So entire value will be 0. This time you have to initialize it by 1. Yes, Raza, we are going to do that as well. Just give me some time. Let me first complete it over here and then we'll do it in Python as well. Yes. Then I say for I is equal to 1, I less than equal to n, I plus plus. What do I say over here? Fact is equal to fact into I. And after that, we say printf factorial of %d is %d and comma, the first is n and the number is fact. Let us run and check. We are going to check it for 5 factorial. Oh, factorial of 0 is 1. What did I do it? Okay. I didn't take the number as input. Let me take the number as input. Printf, enter the number whose factorial is to be calculated. Scanf %d ampersand n. Okay, so we say, okay, this is what has to be calculated. Number has been taken. I say run. I say I want to calculate the factorial of 5. I did type of 5 over here and I press enter. And factorial of 5 is 120. Correct. Simple logic which can be very easily computed over here. Factorial of 5 is 120. Okay. But if you set it to 0, please understand what happens. If you set this factorial value to 0 and I run it and I give the number as 5 this time, answer would be 0 only. Because every time you say over here, we want factorial into I, it is like saying older value is 0. So 0 into I, 0 into I, 0 into I, and obviously the overall output becomes 0. In sum, yes, no doubt we have to set it. But in factorial, you have to set it to 1. Okay. That was one of the program from NQT. So okay. Okay. What is the question? So please explain the same thing in Python simultaneously. Yes, we'll do that. Then what happened when we replace the variable fact with any other variable? Allowed. Absolutely no problem. Anything is allowed. So what is your name? Your name is Datta, na? See. I'll say datta and datta and datta and datta, and I execute, and let's say I want the factorial of 7. You can see you get the answer. Or once again, let's say I want the factorial of 5 only. We get the answer. So that's fine. It works. Absolutely, it will work. Okay. Clear to you, Datta? The only thing is the reason for taking that kind of variables, Datta, is, it's always good to take intuitive variables, same as that what is required. Oh, what is garbage value? Garbage value is literally garbage. It can be any value, any value. Just to prove it to you, let's see. If I say creating a new project. Okay, let's say n comma m. I have just declared two random variables and I'm just trying to print these two values. One is n and one is m without initializing them. By default, these all are initialized to 0 because this is an online compiler. Every variable which you create is by default initialized to 0, but it is not the case in all other compilers. Only static variables are initialized to 0. This is online compiler, therefore it happens. Therefore, conceptually, what could be the value of this? The value of this could be literally anything. Okay, when I printed this, now I got 0, 0, but ideally you can get a number like 1, 2, 3 minus 16. You can get a minus 2, 1. You can have 25. You can have 1, 2, 7, 5, 6. It's allowed. It can be any value. That is a garbage value. Okay, so it's like, it is like variable a. Okay, this is our computer's random access memory. Okay, and our OS is loaded at various locations. Apart from that, right now I'm taking a Zoom lecture. So let's say this space is taken by Zoom, and there is also online GDB compiler. Let's say this space is taken by this. Once I close any particular application, whatever values are there over here, they will remain. And if this space is assigned to some other variable, let's say like m, then it will hold that older value, which is not the true value. Therefore, these are called as garbage values and they can take up literally any values. Okay, that is one thing. Now, coming on to the factorial program, I'm yet to talk about that. So, yes. Talk long. Yes. Oh, I was saying, I'll come to my factorial program. I want to clear this out. Yes. Now, the problem with this program is this will work if the numbers are small. If the numbers are very big, maybe if I say, hey, what is the factorial of 876? Well, answer is 0. You know why? Because it is going outside the range. Whenever I declare any variable by a data type which is called as integer. So datta is a variable which is declared as integer. Datta can store only the numbers in the range 3 to minus 6, 7 or 2, 3 to 7, 6, 7, minus 3 to 7, 6, 8 to 3 to 7, 6, 7. Yes. And the value of the factorial of 876 is going above this. So we need a more bigger data type. And one of the bigger data type over here, if you want to dive into, is going to be long. Okay. So I say data types in C. Yes. This is the one that we have been using, int. I told you this value, right? Now I want a number which can store bigger values than this. And yes, long int is one of the things like that. And that is going to have some format specifier. So let's say, let's use long int, or we can use the unsigned long int, unsigned long int. Okay. So I say, instead of this, unsigned long int. So what is the format specifier for that? It's not %d, it's %lu, all in small. Here also %lu. These all are small things that you should remember. That's it. Now, if I say factorial of 876, it should not be a problem. Yes, it is still having a smaller range. Okay, let us give slightly smaller number. Let's say factorial of 345. No, it is still going much bigger. Let us say factorial of 78. No, still, it's a very big number. Let's say factorial of 65. Yes, you can imagine factorial of 65 itself is such a big number. And what is the accepted range? Accepted range of unsigned is from here to here. You can I'll just paste this link for your convenience. Yes. So now you understand what is the problem, and this is how you need to solve the problem using the right data type. There is no data type bigger than this. If you say I want to do any operation bigger than this, then long double is the operation. You can use that. It is going to be slightly bigger, but not required. Okay. I mean, these all exist, but we don't require it. Seldom we require it. Okay. I mean that below for new is equal to fact into I. Then you will have to initialize new to 1. Okay, and that will be totally against the logic over here, Datta, because we want to calculate the value of fact into I and store it back into fact, because the multiplication result, Datta, when I say fact is equal to fact into I, that means if I say I have to calculate 5 factorial, which is 1 into 2 into 3 into 4 into 5. Datta, over here, first time when I say fact value is initialized to 1, 1 into 1 has to be stored inside this variable. That becomes 1. Then later on, I becomes I plus plus. So this answer 1 has to be multiplied by 2 and again stored inside this variable only. Because how will I get the older value 1? If I write fact into I, see, next time I want to multiply it by 3, but what? The older answer. So I will have to say fact into I. If you write new over here, then it will consistently multiply the original value of fact, that is 1. 1 will be multiplied by 1, 1 will be multiplied by 2, 1 will be multiplied by 3, 1 will be multiplied by 4, 1 will be multiplied by 5. And that will be stored. We don't want that. So it doesn't make sense. Let us see about the company. Yes, Datta. Yes. Okay. Using unsigned long tail, up to which number can we find? You have to try that. Tejas, you have to try that. I don't know. And no one is going to ask you this stupid question. Okay. You need to check out that. Okay. Where is Tejas? Tejas, be very quick. If I can be so quick in answering your question, putting the things in the chat, you also have to be very quick because we have 70 learners who are listening to us. And if there is a delay from your side, then everyone is holding back. Okay. Okay. Let us now do the same thing in Python. Okay. Now this is the program which you have got in C. Let us try to do the same thing in Python. So what I do, I get to let's go to our yesterday's book. Yes. And what will I say for reference? Let me paste it. Okay. This program is just for reference. Okay. If I want to convert it into Python, what I want, listen to this. Forget about this. Factorial of a number, no? Command X, did it. I want to calculate factorial of a number in Python. Hmm. Wow, done. See how fast it is. For doing the same thing in Python, it doesn't make sense in writing the code. No one is going to ask you, how did you get it? However, if you want to write it from the scratch, you can do it over here as well. But let me tell you what I did over here first, and then I can tell you. So see, in Python, there are various header files. Okay, in Python, there are various header files. So where are we? How can I, did I close that window? Uh, Okay, first let me explain you. In Python, there are various modules. One of the module is called as mathematical module. In this mathematical module, there are various functions available. Some of the functions are sine, cos, tan, asine, log, log 10. We have functions like factorial. And if you have to use that, you just need to include it. And for including it in Python, we call it as you need to import that particular package. How to import that? For importing a package, you just need to write import followed by the module name. And after that, if you have to use any function, you need to write math dot, and then I can say, hey, I want the sine of 90. And you get the answer. I can say math dot So many functions are available. You can check it now. So many functions are available. So let's say factorial. I want the factorial of 7. You get it. And if you are tired of writing math dot again and again, you can, instead of doing this, you can say import math as m. And every time now you can write shortcut m dot m dot m dot. And that is the simplest way to calculate factorial in Python. No need to implement a bigger logic. Of course, you can do that. Logic will remain the same. Slightly syntax will differ here and there, but not required. Not required. Okay. So before I go on to the next program, let me confirm. Clear? Yes. Okay. Uh, a function calling itself is called as recursion, Prayag. A function calling itself is called as recursion. I'll take a program on that as well. Let me just check whether does it fall into our list or not. Anything related to recursion. Yes. So anyways, Prayag, we have a session on recursion. We'll talk of that when we come to this particular program. Okay. Let's not talk of recursion right now, but sometime later we will certainly talk about it. Is iterative approach better for this program? No, Tejas, absolutely not. Iterative approaches are always slow. In fact, recursive programs are never preferred. Always non-recursive programs are preferred because they are optimized. Why? We will talk of it when we start with a program with a concept of recursion. Okay. Any more questions? I got to go to the next program now. Perfect. Okay. There is a slight delay. There is one important announcement for you all. And from tomorrow, the session will be directly broadcasted only and only on the app. So if you are interested, you have to register yourself on the app because there will be no session which will be live streamed on the YouTube. I guess these sessions which are also there on the YouTube, they will be removed from the YouTube and everything would be made available to you only and only in the app. So everyone please make a note of it. I'll repeat it again by the end of it. Everything will be made available in the app. Okay. So you will have to join it. And there is, as far as the delay between my speaking and your messages are concerned, in the app, the delay is minimized. I don't say it's zero because we are streaming something. It always takes some amount of time. You use any super quality connection, any high speed connection, this short delay is always going to be there. Uh, oh, great. App link is available in the description. Superb. Superb. So you can see, yes, this app. Okay, this is the link for the app. I guess everything is available over here only. Thank you. Thank you, Vortex. Let's go ahead. The next question. This thing or this logic is very much important. Reverse a number. This is what we are going to study in Python as well as C. But before that, let's understand the while loop in C. So syntax. As far as the syntax of the while loop is concerned, I would say it is slightly tedious. First, we need to write initialization. Then we have while followed by condition. Then we say do this, and then you have the increment or decrement, and after that it is the end of it. That's how the while loop has the syntax. Initialization, while condition, increment, decrement. These are the three important parts of the while loop. Okay. So for example, if I say I have to print the numbers from 1 to 5, okay, this is what is the output I require. Then first thing, I will have to declare an integer. Okay, this is declaration. But let us start with our very first step. First step is initialization. Initialization is I initialize I to 1. Second step is while followed by condition. While I is less than equal to 5, because I have to go up to here. Then inside this, I can do anything. So I can say printf %d comma I. What is that going to do? It is going to print the value of I, and then we say I is equal to I plus 1. That is the third. This is called as increment. Let us try to understand this. So here I say I is initialized to 1. Is 1 less than equal to 5? Yes. Print 1. Printed. Then I is equal to I plus 1. I becomes 2. After this, control jumps back over here. It will check, is 2 less than equal to 5? Yes. Come inside, print 2. Okay, printed 2. Obviously, it will be on the same line, but I don't have space. I is equal to I plus 1, 3. Go back up. Is 3 less than equal to 5? Yes. Print 3. Done. 3 equal to 3 plus 1. That becomes 4. Then go back. Is 4 less than equal to 5? Yes. Print 4. Done. I is equal to I plus 1. That becomes 5. 5 less than equal to 5? Yes. Print 5. Okay. I is equal to I plus 1. 6. Check, is 6 less than 5? No, that means end of the while loop. And this is exactly how the output is going to look like 1, 2, 3, 4, 5. Okay, so that's the basic working of the while loop. And you know what? It's going to look the same. So can we have voice conversation in secure app? Yes. Then Prasan, is it clear? Anyways, I'm going to explain this once again. Initialization followed by condition followed by increment or decrement. Clear to you now? Prasan Jain and everyone. Is this basic program which we did? It's clear to all? Because the next one then we have to start is the reverse of an integer. Prasan, there is absolutely no difference between for and while. There are no proofs who state that for is better than while or while is better than for. They are just alternatives for loops. Okay. For and while are loops. Any program which can be done in a for loop can be done in a while loop, and anything in while can be done in a for. They are just alternatives for each other. Just like I plus plus and I is equal to I plus 1 are one and the same. The same thing happens over here as well, Prasan. Okay. Very good. Very good. Chalo. Let's go ahead. Now the next program, the last one for the day. Reverse and integer. Okay. Reverse and integer. That is, if the number is 1, 2, 3, 4, then the output should be 4, 3, 2, 1. I need to reverse it. Okay. What is going to be the logic for this? Let us try to populate. So here I say, if the number is 1, 2, 3, 4, the first thing is I have to get this number. How will I get the last digit from this number? So I say, okay, what if I say 1, 2, 3, 4 mod 10? Yes, if I say modulo 10 is going to do what? It is going to get the last number 4. 1, 2, 3, 4 modulo 10 is going to give me the answer as 4. Yes, if you are finding it confusing, if I say what is 34 modulo 10, 34 modulo 10 should give me 4. Let us confirm it. So I say 10 threes are 30, remainder is 4. Okay, if I say what is 173 modulo 10, it should ideally give 3. Let us check it out. 10 17s are 170, remainder is 3. So last digit is opted. So I can say, okay, when I do this, I get the number as 4. Okay, where to store the number? Well, let me store this. Let's say this is how I calculate the remainder. So this is my remainder, which is equal to whatever is the number modulo 10. So I say my remainder will be equal to number modulo 10. Then Next thing I say, how to store it in the reverse. So I say, I want to calculate reverse and I'm going to store this in the reverse variable. How? Well, I say my reverse will be is equal to, let's say, I need to initialize reverse. So let us initialize reverse to 0 first. So I say reverse is equal to reverse into 10 plus remainder. What does that mean? Let us check. What is reverse? Reverse is 0. 0 into 10 is 0 plus remainder 4. So that is 0 plus 4, which is equal to 4. So reverse is storing 4. Third, I say number is equal to number divided by 10. Number divided by 10 gives me quotients. You saw it. 34 divided by 10, quotient is 3. So everything other than the last digit is the quotient. 173 divided by 10, 17 comes over here, 4, 3 comes down. So if I say over here, 1, 2, 3, 4 divided by 10, that is going to be 1, 2, 3. So I say whatever is the answer, store it back into number. So my new number becomes 1, 2, 3. Now see, I repeat the same things again. Now I have 1, 2, 3 as the number. I say what is 1, 2, 3 modulo 10. That is my remainder, which is 3. Then I say reverse is equal to reverse into 10 plus remainder. What is reverse? Reverse is currently 4. So reverse is equal to reverse into 10 plus this is the remainder. 4 into 10 is 40 plus 3, 43. 43 gets stored over here. Then I say number is equal to number divided by 10. 123 divided by 10, that becomes 12. Now I have 12. 12 modulo 10 gives me 2. Then I say reverse is equal to reverse into 10 plus remainder. So what is the value of reverse? 43. So that is 43 into 10 plus remainder. 43 into 10 is 430. 430 plus 2 becomes 432. Then we say number divided by 10. Number is equal to number divided by 10. That gives me just, what is my number? 12, not this. 12. 12 divided by 10, that gives me 1. Now I say 1 modulo 10. 1 modulo 10 is 1 only. Yes. So 1 modulo 10 is 1. That is my remainder. Then I say reverse into 10. That is 432 into 10 plus 1. That gives this as 4321. Oh my God, I got the reverse. Congratulations. Then I say number is equal to number divided by 10. So 1 divided by 10 gives me 0. The moment I get 0, I should stop. Why should I stop? Because the reverse is obtained. Na? That was the aim and we were able to get it. So we stop over here. So we are going to do this unless and until we don't get a 0. And yes, this is the main logic behind it. Let me confirm it to you. Ujwala, I said the same thing. No loop is faster. They are just alternatives for each other. You will not find anywhere written anything saying that, okay, this loop is faster or this loop is slower. No, absolutely nothing like that. Execution wise also, they are the same. It depends on program what you are solving. Okay, so is the logic clear? No, Tejas, you can't do it. If you do that, you are messing up with the entire operation. Division has to be done at the last only. It has to be done at the end. Okay. Now we are going to implement this program in C followed by Python. Okay, that will be the aim for the day. Implement the same program in C language followed by Python. Can you please do a fast repeat thing? I'll do it once I do it in the program. Okay, let me write the code and then we'll fastly repeat it. That will be easier because anyways we have to do this thing twice now, once in C, once in Python. So obviously the revision for this is going to happen. Okay, so now let's create a new project. Yes. Void. Okay. So I say number. Then obviously I am going to use the reverse variable and remainder variable. Then I say printf, enter the number to be reversed, then scanf %d ampersand number. Okay, now let's start with the logic. What did I say? First you need to do the initialization. So my initialization is already done because my number is ready. Now I say I will have to set my reverse to 0. Then I say while my number is not equal to 0, till that time I will have to continue the procedure. What is the procedure? First you calculate the remainder. Remainder was what? Number modulo 10. Then we say reverse is equal to reverse into 10 plus remainder, and then we say number is equal to number divided by 10. Once that is done, we just say printf reverse of %d is %d. First %d is end, second is reverse. Let us first check it out and then I will do it. So run. Remainder is declared, reverse is declared. What is not declared? Number, N-O-N-N-N. Okay. Enter the number to be reversed. Let me refresh it. Yes, run it now. 1, 2, 3. The reverse is 3 to 1, but the reverse of this is this. Do you see what is happening? Let me explain you the things now. Okay, this is the main program. What is happening over here? First, you initialize reverse to 0. Let us do it. Okay, you had a question. So what X? See, listen, reverse is initialized to 0. Then I say while number is not equal to this. So number is what? Number we are giving as 123. So is 123 not equal to 0? Obviously, coming down, remainder is equal to 123 modulo 10. So that becomes 3. Then we say reverse is equal to reverse into 10 plus remainder. 0 into 10 is 0 plus remainder is 3. So that becomes 3. Then we say number which was 123, number will become number divided by 10. So this becomes 12, na? Yes. After this, control jumps back. Is 12 not equal to 0? Yes. Remainder is equal to n mod 10. So 12 mod 10 is 2. Reverse is equal to reverse into 10 plus remainder. 3 into 10 is 30. This is 30. This is 30 plus remainder is 2. That becomes 32. So this becomes 32. Okay. Then control goes back. Is 12 not equal to 0? Oh, I forgot. N is equal to n divided by 2. So this becomes 1. Then it will go up and check. Is 1 not equal to 0? Yes. Remainder is equal to number modulo 10. 1 modulo 10 is 1. Reverse is equal to reverse into 10 plus remainder. Reverse is 32. 32 into 10, 320. 320 plus 1, 321. So this gets replaced by 321. Then n is equal to n divided by 10. N is equal to n divided by 10. So 1 divided by 10, 0. Now it goes back, checks. Is number not equal to 0? No, it is equal to 0. So while loop will not execute. So this will be skipped. And I go to this line and I say reverse of %d is %d. And by logic, we know that this is going to print the value inside n. This is going to print the value inside rave. What is the value inside n? 0. We change it every time by saying number is equal to number divided by 10. And what is the value inside rave? That is 321. That is why you see reverse of 0 is 321. We don't want it to happen. So what to do? The Jugaad says, the moment you get a number, why don't you create a copy of that number? So I say on the next line itself, whatever is the number, I'm going to store it in the variable called as copy. And now I have anyways not touched copy anytime. So when I print copy, that should not be a problem. So when I execute this and I type 123, now I get it properly. Reverse of 123 is 321. Again, if you are going to use really big numbers, then it is going to be a problem. You have to use a bigger data type. But if not, then absolutely no problem. It's perfectly fine. So that is how we implement the things in C. Okay. Now going on to Python also. You got it now, Vortex? Very good. Very good. Vortex, I think it's now clear to you. So please type prime number questions in Python. We'll do it. We'll do it. Raja, first let us do this. Tomorrow we'll do that as well. We are in the flow of this. We'll do it over here. So, yes. Coming on to this, what we have to do, reverse a number. No? So let's say reverse a number in Python. So you have to take a number as input. Okay. So Python says, okay, you want a number as input. So int of input. I hope you remember. It's very easy. Then syntax for while, slightly different. How? Well, it's like this. Let me write it in text. Initialize it. Then while followed by condition. Then in the tab here, you write do this, increment or decrement. So that is how is the syntax of while. So this is how it comes when you cover it, but no problem. You double click to see this in Google Colab. It will else not come in the right format. That's fine. That is how it is expected. Now here I say, I need to declare a variable called as rev equal to 0. Let's say reverse is equal to 0. Then what is the next thing that I do? Well, I say while my n is not equal to 0 colon. That is the syntax of Python. Automatically it will come inside. Then we say my remainder. I need not declare it. I'm saving the value right now. So I say remainder is equal to number modulo 10. Reverse is equal to reverse into 10 plus remainder. And then number is equal to number divided by 10. Sorted. Then you say print reverse of comma will store in the copy equal to n. So reverse of copy is reverse. Let's execute and check. Oh, what logic did I do as blunder? 123 is the input. Reverse of 123 is this remainder is equal to, let us set remainder also. Oh, what did I do it? Copy is n, that is fine. Then reverse equal to 0 while number is not equal to 0. That's correct. Remainder is equal to number modulo 10. Reverse is equal to reverse into 10 plus remainder. Number is equal to number divided by 10. That is correct. What is the problem? Reverse has gone to infinity. Why? Reverse into 10 plus remainder. Let me write this in bracket. Why is it doing? Why is it doing? Let me check. Print, just printing rev in between just to check what is the problem that it is doing. Yes. So this doesn't work in Python. This for Python, if you want to get the quotient, I told you last time, right? You need to write divide. I'll tell you why. First, let me explain you that. Let's say if I have a number like 13, if I say what is 13 divided by 2 in Python, please observe 13 divided by 2 is like 6.5. But let us say I want the quotient, then I will have to write divide. This is called as the floor division. Floor division gives me the quotient. 2 6 are 12. And I also told you that if you want the remainder, it is 13 modulo 2.
It's 7 o'clock.
So this operation is called as modulo. Yes. So here, that is exactly the problem. So I need to write it like this. Now when I say 1 2 3, yes, you can see the answer. Reverse of 1 2 3 is 3 to 1. Now this line is not required. I can just get rid of this. Enter. 1 2 3 is 3 to 1. It works. Simple. So that is the basic syntax how to do the same program in Python. Okay. Clear? It will be 143. It will not be 0143 in that case. Vortex. Oh, increment forgot. In this case, there is no increment decrement required. Okay, depending on the condition, it is required. If you don't give it, it can go into infinite loop as well. I'll tell you, let's say if I have to print, let's say natural numbers from 1 to 20. How will I say? I will have to initialize I is equal to 1. Then I say while I is less than equal to 20, print I comma end equal to space, and then I say I is equal to I plus 1. Please make a note. I plus plus does not exist in Python. And now we can see it is going to print numbers 1 to them. Here, if you forget to increment, in this program, it is required. Here, if you forget to increment, what is going to happen? Let's try to understand. So I said I have initialized I to 1. What is now understand? I check is 1 less than equal to 20. Yes, it is going to print 1. And let's say if this line does not exist, then after this, automatically it will go up. Check is 1 less than equal to 20. Yes, so print 1. Again it will go back and check is 1 less than is equal to 20. Yes, print 1. Again it will go back and check is 1 less than equal to 20. Yes, print 1. And we understand that it is going to print 1 infinite number of times. We don't want it to happen. Therefore, in this case, we understand that increment is compulsory. Okay, in the older case it was not, but here it is 100% compulsory. Yes. Can you show the code again? Yes, definitely. So see. Now, why to show the code again? This is the code. This is the code. This is the C code. Okay, you can check it. This is the link for it. You can check the skin. How to do %.3d in Python? That is slightly tedious in Python. You can do that as well, but again, not required. Not required, Raza. Understand? You are not learning language as a programming language right now. We are trying to understand the problem from the TCS NQT perspective. If you waste your time in all these things, none of this is going to benefit you. And it is very simple. It is very simple over here. If you want to find how to do %.3d, just go to Google and find out. It is just a symbol line. Okay. One more thing. What is end equal to? I explained it last time. End equal to is used for ending this thing. Let's say, for example, if I say end is equal to vertex, after every time it prints I, it will print vertex. See, 1 vertex, 2 vertex, 3 vertex, 4 vertex. Every time it prints, it is going to print vertex. If I say star star, then after every character it is going to print star star. But what I want after every character it prints, I want a space. Therefore, I say end everything with a space. If you don't do it, by default, it will end everything with a new line. For example, if I add a cell, let's say if I don't write my end equal to, then it is going to print everything on a new line. Because by default, it will always go to a new line. I don't wanted a long list to come over here. Therefore, I did write end equal to space. Clear? Perfect. So let's call it a day then. Thank you very much. If you have any questions, please let me know right now. Else, in next 1 minute, I am stopping the stream. No, Vortex, these all things won't come. They are not checking. See, TCS is not interested in your formatting skills. TCS is interested in your logical skills. Understand, no company requires a architect over here who can decorate the code. We require a person who can write a code. Okay, so these all things are not mandatory. For your coding skills, your logic is something which is most important. I did it like this only. I don't want the things to be there on different lines. Therefore, I did end is equal to space. Yes, I'll share it. I'll share it. I'll share it. What is today? Today 20. Yes. So this is one of the link. And this is the second link. Yes, you can refer it over here. Okay. An app link is in the description. Please observe over here in the description. We have the app link here. Where was it? Yes. Download the learning app. Please follow this to join it. Okay, cool. Let's call it a day. Thank you very much.
Thank you, sir.
Chalo. I'll stop the stream. Bye-bye.